Have you ever opened a really complex website, one of those interactive apps, and just stopped and wondered, how in the world is this even built? I mean, how do you go from a totally blank screen to a living, breathing digital experience? Well, that's exactly what we're going to break down. Okay, let's dive in. So we're going to approach this just like we're building a house. First, we'll lay down the bare bones skeleton, the structure. Then we'll bring in the designers to handle the look and feel. After that, it's time to flip the switch, run the wiring, and bring the whole thing to life with logic. Then we'll look at the power tools that let us build skyscrapers, not just small houses. And finally, we'll get inside the head of the architect who puts it all together. All right, every single page on the web, and I mean every page, from the simplest blog to a huge social network, it all starts right here. It all begins as a simple text file, a blueprint that gives the entire thing its fundamental shape and meaning. And that blueprint is written in a language called HTML, which stands for Hypertext Markup Language. Now, it's not a programming language in the way you might think. It's a markup language. Its only job is to describe the content. It says, hey, this chunk of text is a heading, or this part is a paragraph, and this right here, that's a link. It's the steel frame of our building. And you can see just how simple it is at its core. You just wrap your content in these things called tags. See that H1? That makes a big heading. The P tag makes a paragraph, and the A tag, that stands for anchor, creates a link you can click on. The browser reads this blueprint and knows exactly how to arrange everything, even before a single drop of paint is applied. So we've got our raw structure, but let's be honest, it's not going to win any design awards just yet. This is where the next layer comes in. We need to go from that bare frame to a place that has color and layout and a real personality. We need to add some style. Now, here's what's so cool about this. The HTML, the actual content and structure on the left and the right, is exactly the same, 100% identical. The only thing that's different is that we've applied something called CSS, or Cascading Style Sheets. CSS is basically a list of rules that tells the browser how to display all that HTML. It controls the colors, the fonts, the spacing, pretty much everything that makes a website look good. So you might be asking, why do it this way? Well, it all comes down to a really important idea called separation of concerns. By keeping the structure, the HTML, totally separate from the presentation, the CSS, the whole system just becomes way, way easier to manage. You could change the entire look of a massive website just by editing one single CSS file without ever touching the actual content. It's all about being efficient and staying in control. Okay, our building is looking sharp, but it's just a static model. Nothing happens when you flip a switch or press a button. To make it truly interactive, to turn it into a dynamic application, we need to wire it up. We need to give it a nervous system, a brain. We need to add logic. And that brain is JavaScript. It's a proper programming language that runs right inside your web browser, and it can manipulate the HTML and CSS of a page on the fly. It basically just sits there and waits for you to do something, like click a button, scroll the page, or type in a box, and then it executes a set of instructions in response. This is the moment a static document becomes a living, breathing experience. Let's pull back the curtain for a second on what's really happening. When you click a button to, say, open a menu, you're kicking off a simple algorithm, a recipe. The browser detects that click. That click triggers a function, which is really just a named list of instructions we wrote earlier. And those instructions tell the browser, hey, go change the CSS on that menu to make it visible. It's a very clear, logical chain reaction. And as you get deeper into programming, you start to realize it's not just about brute forcing things to work, it's about finding elegant solutions. This quote really gets at a key idea. The best code is just a clear reflection of the thinking, the algorithm behind it. The goal is to solve the problem in a way that's simple, clean, and just makes sense. Okay, so HTML, CSS, and JavaScript, those are the three pillars. But let's face it, modern websites are unbelievably complex. Building them with just those basic tools would be like trying to build a skyscraper with a hammer and a bag of nails. I mean, you could probably do it, but it would be painfully slow. Instead, modern builders use power tools and prefabricated parts, and in the web world, we call those frameworks. So on the left, you see an old school way of doing things, just writing directly to the page. It works, but it doesn't scale. On the right, that's the modern way, building with components. The best way to think about them is like superpowered, specialized Lego bricks.
Each component is its own little self-contained piece of the website, like a search bar or a like button, with all its own structure, style, and logic bundled together inside it. So today, a big application isn't built as one giant single thing. It's assembled by snapping together hundreds of these little independent components. This makes building things so much faster and more organized. And when something breaks, you can just focus on that one little Lego brick without worrying about the rest of the castle.
And the world of tools around this is just massive. For instance, Node.js was a total game changer because it let developers use the same language, JavaScript, on the server and in the browser. Then you have things like TypeScript, which adds safety rails to JavaScript to help you catch silly mistakes in really big projects. And finally, you have build tools, which are like an automated factory that takes all your hundreds of code files and bundles them into one small, fast package to send to the user.
So we've covered the what, but maybe the most important part is the how and the who, because all this technology is just a set of tools. The real work, the real skill, is about a very specific way of thinking. It's a problem-solving mindset. I absolutely love this quote because it gets to the real heart of what being a programmer is all about. It's not about being a genius who writes perfect code from the start. Not at all. It's about trying something, watching it fail spectacularly, figuring out why it failed, and then fixing it. Real experience isn't about knowing all the answers. It's about having seen and solved thousands of problems before. Ultimately, programming is the craft of untangling chaos. It's the methodical skill of looking at a huge, intimidating challenge and breaking it down into a series of tiny, simple, solvable little pieces. It's a creative act for sure, but it's a creativity that's guided by pure logic and improved through the constant practice of solving puzzles, one error message at a time. So, we've pulled back the curtain. We've seen how the digital world is really built, from the blueprint of HTML to the brain of JavaScript and the mindset that ties it all together. The web isn't magic. It's built with tools and logic. And that really only leaves one question left to ask.